by this code of conduct, which Joe may pop up on the screen, or maybe I will just riff for a second. And then remember, the short version of this is that we expect folks to be nice, to be respectful and constructive, to be collaborative, and to participate as part of this community. There actually is a much longer version of this, which we usually have a link to somewhere. But if you have any questions, feel free to reach out to one of the organizers or to the GDG in general. Looks like we have another person joining us, and so the group is continuing to grow. And we will get started in just a second.
Sorry, this hummus wrap is so good. I'm just really.
It is really good. I'm trying to finish it so we can start with the magic.
Let it get cold. My apologies to folks that aren't here to eat the hummus wraps, but do join us, and we'll see if maybe we can get sponsorship for a virtual event. I think we know some groups where they actually send out Grubhub codes.
Yeah, we've had a little complication where there's like an in-person event and a virtual event, and a hybrid event, according to Google, is an in-person event. So it only includes like the in-person support. But we'll work on that. We still have several more sessions to go.
Cool. So jump into it. We're in week 2 of the professional cloud developer path. And news and updates. I think we already touched on that. We spoke around the horn here about introducing folks. Did you get to introduce yourself?
No, not yet. I wasn't able to make it last week.
Okay, gotcha.
Yeah,
Welcome.
sorry for coming in late.
No worries. We were just getting started, so you came in right on time. And is there still food left?
There's still food left.
So you're perfect timing.
You can't be late at this food. So we did that earlier. If any folks want to share more remotely, please just throw it in the chat there. Shout out, of course, to Peter Bishop, who we've got joining us from Wayfair. We've got Tom Newman here, Core Infrastructure. We've got Norbert joining us as well, another organizer, database specialist, BigQuery. A lot of awesome folks. Thank you, everybody. And one thing I wanted to throw here in the news section is Quick Labs. So I know we say it's Cloud Skills Boost. It's a rebranding of Quick Labs. And when you're in there, you're going to see URLs that say Quick Labs because it's still Quick Labs, essentially, okay? And so Quick Labs has something right now, a special thing they're doing called their arcade. So if you'd like to join that, there's the link for it. It's goquicklabs.com/arcade. And they have 4 Diwali themed challenges you can go through if you'd like. And of course, this gives you more badges that you can hang on your wall. There's some folks that have insane numbers of badges. What is it? John, the head of the Wally GDG, he's got I think every badge there is.
Oh my goodness.
Some folks are into that. They have challenges. I personally did one of these challenges a few weeks ago called Clout to see how fast you could do some labs. And they sent me a free book, a pretty awesome book, which I'll show some pages from.
Yeah, we should recommend folks can actually access that book via GitHub.
Yeah, so just wanted to note that there's a lot of neat things going on there. It doesn't just have to be learning about how to deploy the cloud run. If you're wanting to working on staying current with these cloud skills, there's actually fun games that they put out there, and there might be some prizes, these sort of things. So you guys can check that out. This week, touching base on where we are in the journey. We're in the second session, which means that we're going to start talking about everything that was more or less assigned for the prior session. Now, no one's grading your homework. If you didn't do anything, welcome. We all have our lives. We're all very busy. But we're going to try to go over, what that last section covered, and then we'll talk about what, if you want to stay on pace, you would do for this week. And we'll touch on that in just a second here. Obviously, we're going to talk more about the exam guide and some stuff that's in there. Go through some sample questions, Q&A for really anybody that got caught up on things that might have been challenging, and any of those exercises we were doing, and then talk about what we're going to go through next week. And again, when I say staying on track, it's the idea that after 6 weeks, getting together, collaborating on some of the stuff, helping each other out, and working at home, you'll feel more comfortable trying to jump into that exam. And I'm sorry for anyone who's in college, exam, I know it's a really scary word. At least for those of us who aren't in college, it's scary. So touch base where we are. This is essentially the syllabus. And last week we went through some from this section here. which I'm really sorry, Lucas and I picked the only thing which is not actually required to do. So the rest of these would be suggested that you do these. This one is just kind of like cloud kung fu if you really wanted to go out on a limb, which can be done. That's why I stayed up till 11 o'clock on Tuesday night. You don't have to do that though. But the cloud fundamentals of core infrastructure is what we started working with over the last week. So we'll be touching on that. And then this week, the stuff you'd start working on would be application development, which is really awesome. Like this is actually, hey, I'm going to make an app, I'm going to throw it up there, I'm going to see it running in a few minutes, right? The sort of thing that you can actually use today. You can put your blog up. There actually is an exercise in here doing just that, showing you how to host your blog, basically for free. That's basically how I host mine. Hey, welcome back. Got some extra food here. We'll hand out the swag later. And we'll probably figure out how to do this later on, but we also have swag showing the offering plate here to the camera that we got from Study Jam. We'll try to see how we can hook up folks that are remote as well. So this is our journey that we're on right now. As I mentioned, we're talking app development up here. And also, we're going to talk about Firebase development. And Firebase is one of the core serverless offerings. Does anybody know what serverless is? Anybody worked with serverless before? So, Dinesh, what is serverless?
Essentially, it's to kind of create small functional units of comp power, and you don't have to basically host a VM or something at a server lab in Iowa or something, or any other room. So that could be in the form of like cloud functions, schedulers.
Well, somebody did their homework.
Yeah.
And I think the key thing you said, right, serverless, you don't have to have a VM. When Lucas and I wanted to make a blog in 2008, you spent a week trying to get your LAMP server working, your Linux, Apache, MySQL, PHP server working. And only at the end did you put your blog up, right? You were trying to get all these other pieces put together. Here you'll see in this lab for the serverless application development that you can just do this in like no time. And you don't need a server. And it also means you don't have to really pay for anything. If you run your blog off one of these serverless offerings, you'll probably stay under Google or Amazon free tier if you use those. Like you're never going to pay a dime. Whereas I used to pay $80 a month. So serverless though keeps on scaling beyond that too. Like we run a lot of stuff at Mabel where I'll say, hey, we called this thing 100 million times this month, and we paid like $50 because again, it really scales well. I was just running a demo. We made 100,000 API requests to do a load test, did it serverlessly, and it cost me 2 cents. So serverless is really awesome, and you guys should definitely check it out. This is some really awesome labs. The rest of this we'll touch on in later weeks. Oh yes, and Norbert also raises a good point about BigQuery. We haven't gotten into BigQuery yet, but it's also a serverless offering. No more maintaining your database servers. You can store trillions of rows, and it just works. Cool. So let's touch on the exam guide a little bit. So in week 2, that's really going to get into core infrastructure. And I think, what was it? Norbert's mnemonic for this was Crosby, Stills, and Nash, I think. Right? That you have your compute, right? We have to actually have a CPU somewhere that's doing computations, right? We have to store stuff. So we need storage, whether that's memory, disks, whatever we're storing it in. We need networking down here, and we need security, IAM, right? We can't let just anybody go in there and mess with stuff. Now, if you were hosting a blog in 2008, I don't know what security was. Anybody could take over your blog, but today, security is built in. So these are some of these very core pieces. And even kind of expansions these days is also big data and ML, machine learning. But that, as Norbert pointed out, with things like BigQuery, that's also a serverless thing we don't really have to worry about. We make that someone else's problem. Also touch on virtual machines in the cloud. Now, you guys actually saw last week we were spinning up virtual machines. If you've done any of these exercises, you've seen virtual machines come up and down. You should also be aware that there's many kinds of virtual machines. There's like the F1 micro instance that costs nothing. And then there's the C2D112 with like a terabyte of RAM, like 120 processors, 8 GPUs. And that thing's going to cost you a lot of money.
But that could handle the load on my blog for sure, right?
Well, that is guaranteed by Google to handle 100 gigabit per second
Oh, that's excellent.
So that's a busload, as they say. As Norm points out, they're good old-fashioned big irons. There's all sorts of virtual machines to choose from. Storage, something definitely we'll get into. Containers. Anybody here ever work with Docker? I'm sure someone's worked with Docker before, right? How old's the whale now? It had its birthday, right? It's like 5 years old or 6 years old.
Oh, that sounds about right.
Yeah,
Yeah,
so-
it's not that long.
But
It seems like an eternity, but
Containers have taken over the cloud. Apps, which, as you would have seen in some of those examples of Firebase, and with these other deployment mechanisms, there's a lot of passive. Is that how you pronounce it, Kat? Was it pass? Yes.
it was IaaS was the one I had never really considered how that IaaS was pronounced,
Okay.
and then I watched the videos for the first session, and it's IaaS, and I was like, okay, like I just never said it out loud before. Yep.
Is that infrastructure as a service?
Yeah.
The far end of that. So we have platform as a service, right? Where you're like, look, I just want to run this app. I don't care where you run it from, right? And then you get all the way down to like functions as a service. That's kind of like the furthest end, where you're like, here's just a little piece of code. Like, here's 10 lines of code. I don't care how it runs, where it runs, just run it for me. Back in Lucas in my day, infrastructure as a service is where we were. We were like paying people lots of money to stick computers in racks. You guys hopefully never have to see a rack of computers. And then finally, monitoring is the final core part we'll talk about here, because monitoring is, if you're running everything in the cloud and it's not working right and you can't tell if it's running, like if a tree falls in the forest and no one hears it, then is it really running? And finally, for this week is a case study. And again, remember, we talked about the case studies being important because on the exam, the case studies are going to say, like, not pop quiz, what's the best, what's your favorite storage? It's going to say, for this company, trying to solve this problem, what's the best answer? And we've got a few fans in the chat there. Yes, big fans of Docker.
Yeah, I don't really know how I would go back to not using Docker in my process anymore. It just improves so many things that I won't give it up.
Yes, it's a good time to be coming out of college because I wasted a lot of time trying to just get things to work, get servers built. Cool. So let's talk about a few exam questions here. We're going to try something new this week. So let me see if I can get my Kahoot working. So
Amazing.
I think I'm going to just log in. So there's a gamification platform called Kahoots. Study vote. Play. So let me just get you our Kahoot, and I'll share that link in the chat for everybody. All right. Sorry, it's my first time Kahooting. But if you join any of the other Google meetups, they actually do use that too. Started. 1 second. Start button doesn't work. All right. One more try here, and then we'll just do it the old-fashioned way. Keeps trying to get me to upgrade. Wait, here we go. Yeah. So we're getting our pen. Stand by. All right. So if you guys just want to go to kahoot.it, and here's our pin code. I'll paste that in the chat. Thank you for your patience.
It's pretty spooky.
Oh yeah, Kahoot is a wonderful user interface. So there's a link for folks remote where they'll just take you straight through. If you guys just go to kahoot.it and type this in. Okay, we've got some fish. Let's see, a duck. Everybody's joining in here. Look, should there be like a swag prize? Like, what are we giving away here?
Oh, do you
Tell them
have
what they won?
do you have a thing that isn't already out on the table?
Okay, let me dig around in the sack of swag over here.
Yeah, we gotta find some good stuff.
For this week's prize run, we have a Google Cloud lunchbox. What van to get this open for you? Complete with a Google Cloud water bottle. Yeah, okay. And if a remote person wins, we'll see about how to get it to you. Don't worry. All right. So we'll put the Triumph out here. All right. We got some folks here. Cool. So I'm going to show the question. I'm going to show the questions up here, and then we'll show what you guys look like. Just because Kahoot doesn't let you put many words on a question. So we'll see them up here, and all the choices will be in the Kahoot screen. Let's give this a try. Yeah, let's skip through this one. We'll come back. All right, there's our Kahoot. All right, so instance templates. All right, I'm going to start it. Second. All right, so instance templates are used to create a group of identical VMs. The instance templates include what? So here's our voting. It'll take 20 seconds overall. So when you're making an instance template, do you set up a load balancer? Do you set up App Engine? Are we working with cloud storage buckets? Or is this configuring a machine type? All right.
Oh, good timing on your delivery.
Who's going to
there.
win now? Everyone got it right. Oh, okay.
We should have harder questions, obviously.
Yeah, we need harder. Next time, there's going to be a lot of harder questions. You guys are too smart. All right. So everybody is winning. Okay, so no.
Oh, but there's a time aspect to
Yeah,
this.
there is a time aspect here.
Yeah, the quicker you enter your answer, the more points you
So
get.
way to go, Sim. All right.
Click on the thumb.
Oh, well, you know, machine is the right answer. So we'll just talk through this real quick, and then we'll go to the next question. So remember, an instance template, we used one last week. It's if you really want to start stamping out machines, if you want like 100 of these, you don't want to go configure each one. You also don't want to have to tell Google how to configure each one. So you can actually say, here's an archetype. And then if I want 10 or 1,000 or 10,000 of them, Google will just make the same thing. And so, yes, if you define your instance template, you say like this kind of machine, this kind of hard disk, because there's slow hard disks, there's fast hard disks, big and small. There's even with like hyper disks now. They have a new super hard disk. If you want like hundreds of thousands of operations per second.
And you can have disks that are persistent and
Yeah.
disks that are not persistent.
Yes, it really depends on what your workload is. The container image, because you don't have to use a disk, you can use a container. And then zones and labels, because remember, you can run your computer in different places, and so you want to say what those are. Cool, so that is the answer there. Let's click through. So here's the next question. I'm going to hit next here. Just bring up the next question. So the command to make a cloud storage bucket. I need to make a new cloud storage bucket. What do I do?
I think it's a trick question.
We'll get into why it's a trick question in a minute. All right, what do we got here? All your votes in, everybody. Zeben is there, right? So G-Cloud make bucket. Ooh, that's what's the right answer?
GSU to make bucket.
Yeah, so it's a trick question only because soon it will be part of G-Cloud.
Yes, in fact, they just announced this week that there is the entire suite of GSU tools available within the G-Cloud tool itself, using either the more familiar G-Cloud syntax or the existing GSU syntax. So folks can basically just drop in G-Cloud storage as a replacement for GSU. And then eventually we won't need to install two separate CLIs in order to work with all the APIs and also storage. It'll be just a single client.
It's worth noting that when you take the exam isn't going to test an alpha feature that just came out this week, right? So that's why the right answer would be GSUtil, which is still the way to do it. Let's see how folks did on that one. Ooh, this song is coming
Oh, well, Sim has a
up.
pretty strong lead, I'd have to
Sim is
say.
moving. All right. We got another one.
But we got movement. I'd like to see that.
All right, this next one's kind of lengthy, so I'm going to leave it on the actual full question screen so everybody can read it. So I'm just going to kick this one over and then go to it. All right. Your company has an object management policy that requires objects to be stored in cloud storage and they need to be migrated to a different storage mechanism after 90 days. The most efficient way to do this is, and this is actually like a real exam question. So do we want a life cycle policy? Do we want to copy it to a persistent storage attached virtual machine disk, migrate it using migrate object after, or use a cloud function that's going to move things around? All right, let's see what we got here. All right, one person. Is this Sim? Let's see what happens. Is Sim a real person or like a bot? I'm not sure.
It's a sim.
Okay, so this one's kind of complicated, and hopefully, you had your GS util Wheaties. The concept here is there are life cycle management policies, right? We mentioned serverless. You don't want to have to go and pick this object up and move it over all the time. What if you forget? So at Mabel, for example, we have billions of objects in cloud storage. And we tell our customers that we're going to hang on to stuff for a certain period of time. But there's also different places you can store things that get cheaper. So as an example, if I need to read and write something all day long, I might want that in what they call their standard storage. But if I'm very rarely going to read it, I can move it to a cheaper place, like what they mentioned here, nearline storage. This is where your price is going to get cut in half or better. The catch, though, is if you start reading it again, they're going to charge you more to read it. You're just putting it there because you don't think you're going to need to read it, right? Like for us, maybe like 0.001% of stuff people are going to export 2 months later. So we move it to a cheaper place. So that's why you want to move stuff. But lifecycle management configuration policies do this automatically. You just put this one property in your bucket and everything's going to move automatically for you. So you don't need to go and make a cloud function. I don't know what this migrate object after is because
they invent things periodically for the test.
And
one thing I'll say is the people who put in A for this, that's not a terrible answer. It's actually, if Google didn't make a magic feature that you can just kind of turn on that does this for you, and if you didn't know that that existed, then the way I would implement this myself is using A. I mean, that is a great approach. It's just that once you did that and then you found out, oh, there's a toggle for this, then you'd be like, oh, why did I do that? But Google's adding features all the time. And even those of us who work with it every day aren't always aware that the thing we just spent 2 hours building is like itself already a feature. And so it's hard to keep on that. So I think that everyone should get some credit on that one personally.
But it says a takeaway. Always be trying to think, is there a feature that'll do this for you? So you don't have to. Because that's going to scale. The code that's going to scale the best is the code in your work.
And the strategy we talked about at the last session of like, are there any answers in the list that you can just like eliminate? And now you're selecting between 3 or 2 things. And, when they're talking about spinning up VMs and doing a bunch of stuff on a VM, it gives you a sense there's got to be a better way to do that.
So takeaway about the efficient, right? They didn't say a way that you could do this, but what's the best way to do it? Cool. So let's see what we got here. Sindhu. The podium. All right, Mr. Fish. Congratulations. Oh, pardon me. Excuse me.
Miss Fish.
Congratulations.
Excellent. So what are we doing? Are you shipping this out? Do you have a FedEx account or something? You can
credit card, personal savings account, but can SIM identify themselves?
I believe that maybe they have already.
They have?
I think so.
Oh, Simon Choi.
The bot, yeah.
No, what? Simon works here. Son of a gun. Awesome. Congratulations.
Son of a gun.
Well,
there he is.
Ship it. I'll just put it on your desk, Simon.
Yeah, there you go. No shipping necessary.
Cool. Well, thank you.
Yeah, we got a little feedback on the Kahoot, which is understandable. Like switching between the one screen and the other screen, and not having like the triangle or colors to go with, it makes it a little challenging. So we should consider that for the next time.
Definitely. I'll just keep on the same. The challenge for the last one is that Kahoot only lets you use like 60 letters.
Yeah,
So you know
yeah.
what? I'll upgrade to Pro, and then we can probably use more letters.
Well, you know what we could do? Maybe there's a way that we could read the question, but no one knows which answer it is in Kahoot until after we've fully read the question or something. But we'll figure it out.
I think you can also upload images. So you could basically just take a screenshot of the slide and upload that
Okay.
with no text. And then
Anish has already become an expert. You have to.
I've made
Spoiler
many-
alert! For the second week session, that course that you're going to do, one of the things that you do is you create. Google gives you like a little sample code that you upload, and you deploy like a voting app where you create a quiz and you put in the 4 possible answers, and you can upload an image. And the
Yeah.
challenge that they give you is the app is like not working. And it in the user interface, it looks like you can upload an image, but when you look at the code, you can't upload an image. So the challenge is like you have to put in the right code so it uploads an image. But that's one of the things that we do here.
We also got Slido.com.
Yeah, Slido was the other one I was
We'll
considering.
check that out. Who gets not looking at these last night? They all have like silly names. I'm like, I can't remember the right silly name. Okay.
Kahoot was the one we were looking for though, because Google used this at a couple events we attended recently.
All right, so just pause. Make sure we give like an opening for anybody that has been working on any of these labs. Did anyone have any questions or like any like just kind of even subject areas that they were curious about? Around databases, around apps or deployments or anything like that.
Everyone's doing great. Some folks are still trying to make a little time in their week where they can focus on this. So it's understandable. But we are certainly available to help people with things that they run into along the way.
Just remind folks, we do have the questions channel in the Slack. So if folks have, I'll just pull it up in a second here.
Oh, we haven't mentioned the Slack yet during this event. But one of the things about the chat here in the GDG app is that it is going to go away when the event is over. And so we have the Slack here to have a persistent community throughout the duration of this series. So folks can get help in the Slack channels when they're working on this at home or whatever.
So just to give an example here, we've got various people today saying, hey, I'm working on the Kubernetes lab and I thought I did everything right. What gives? Like this doesn't make sense. Why isn't it working? And various people jumping in to say, okay, here, I can show you how to do that. We had another one, Tiber, this morning. Just a lot of various people jumping in here together.
That one was a good one. This one with the screenshot that you're on right there. The user posted a screenshot, which is often helpful, and I caught the issue here. I don't know if anyone else can tell what's going on, but like, there's a weird space that got in there when they were copying the project name, and it went into the thing, and so it was trying to access a project called Space Quick Labs, and it was failing. And so we were able to catch that in Slack.
Yeah, who loves white space languages? Right? YAML is just full of pitfalls. Cool. And with that, we want to jump into one of the labs, Lucas?
I think so.
Can you share?
Oh yeah, sure.
Cool. So let's make sure everybody has gotten access to the Slack channel. I think that there's a 1 second. I'm going to slide up. If you haven't joined us in our Slack channel, anybody new joining us remote or in person, I don't know if you guys are in there. Just jump at that real quick, and that'll get you into the RGDC, the what is it? Our Road to Google Developer Certification. It's a mouthful. Slack channel.
I do not currently have share screen ability.
You don't. All right. Maybe if I stop sharing, and I'll throw it to you.
Oh, that did it. That did
All
it.
right, Lucas is back.
Boom. Okay, we're in Quick Labs. The one issue might be I might have already done this lab.
You can do it again.
Yes.
You can do Quick Labs as many times as you want. They're actually really helpful.
So remind me again which one we're doing today.
Sure. Jump over here.
Is it getting started with
So,
application
getting started with
development?
application development. is
Boom,
what we're heading
getting
to now.
started with application development. Okay, so what I think we're not going to do here is watch the many informative videos,
We're not coming to sit together.
because
and
that's
watch
definitely
videos.
something you all can do on your own time, and I encourage you to do it, because like I said, there were definitely things that I learned in here. So just for your reference, I'll walk you through this. When you get started, the first thing that it will show you is a welcome video. And then if you have autoplay on, it will just play this video that's 2.5 minutes and then just keep playing through the video, so you can kind of sit there and pay attention to it. And then you eventually, after you go through a series of videos, you get to these quizzes. And so
I just thought that the videos are actually very packed with great information.
correct.
Like this is like, you're about to get your like senior engineer job for developing high scale applications.
I mean, so at the Broad, we have a lot of people that come in and then they've not used Google Cloud before, and there's Google Cloud all over, so you have to get them up to speed. And it's like their teammate is teaching them, oh, here's what a project is, and here's how you log in, and what a service account is. And I'm like, oh wow, I just watched a bunch of videos that taught me like all the stuff we try to teach people at work. I wish I could just get them to sit through a few minutes of these videos, and then they'd know all the things. So absolutely encourage you to like go through this.
They're not very long, they're like 2 or 3 minutes.
No, most of them are less than a few minutes. Like I think there was one that was like 9 minutes, but actually it was one of the more informative ones. So I encourage you to do this, but we're not going to waste your time by making you watch YouTube videos together as a group when we can do more stuff. So should we do these quizzes? Is that what you wanted to do? Okay, great. So presuming that you have gone through some of these exercises and looked at a few of the videos, we're going to start looking at some of the questions here. So the first one is, you need to design a social application to reach a much broader audience than before. You want to achieve scalability, reliability, and security. Select the 2 best practices that you can implement to build scalable, more secure, and highly available applications. So the first option, avoid caching to minimize the number of services that your application depends on. Design for loose coupling between application components. Develop a highly secure user management system that you can rely on. Manage your application's code and environment by using a code repository and a dependency management system.
We got an audience here.
Oh yeah, so I'm not as able to watch the chat so much if I'm doing the thing.
Did you choose more than one option?
Yeah, pick 2. So do you think we should avoid caching? Is caching a good or bad thing? What do we think? Mostly good.
I think for one thing, I think caching is generally good for performance, and also like
Is the statement even true? Caching avoids minimizing? Doesn't it actually minimize?
yeah, I mean, if you avoid caching and you think that that's going to minimize the number of services that your application depends on, that doesn't really, I mean, I guess kind of, maybe you're not depending on the image server because you cache the image, but no. So what is loose coupling? What is designed for loose coupling?
Anybody? Any takers in this one?
It's not tightly integrated together, which are not dependent on. But yeah, the services should be dependent, reliable on each of the service, so they should be tightly coupled.
Yeah, exactly. So this is one of the things you'll see in the videos that I actually found really informative for me. And just some of the terminology and concepts. But building these applications with, maybe they have microservices or something like that, different services that talk to each other, and then they have a smart way of behaving when things aren't working. So instead of the whole application falling over, if you can't talk to one of these things, then maybe you show an error, maybe you just don't show something, but they aren't so tightly coupled together that the outage on one destroys the whole application.
You can scale them independently, you can deploy them independently, and as you said, they fail
independently. So now I'm not totally sure how the user management thing fits into this personally. It just doesn't seem applicable to what they're talking about here.
It says you have to build it yourself. And Usually we're going to try to.
Oh yeah,
minimize
why do we want to build our own user management
some of
system?
the big takeaways? You're gonna find all the exams. Hey, let Google do it, and then you can do something else.
So if that were true, then that would leave us with the last one, which is manage your application's code and environment by using a code repository and a dependency management system. I feel good about this one. Also, I will say that if you aren't like a professional developer that's been doing it for years and you don't know like all the things that people do today as far as software supply chain security and automated deployments and CI/CD, that's all in this content. So it's lots of fun stuff.
Pretty much for any exam question on anything, if there's an option to develop your own security anything, the answer is no. Sure. You need to be really, really smart. And
Don't build your own
that smart.
security.
So I agree with you that on the chat that 3 is important, but that's probably why you wouldn't want to do it.
And also, I don't think 3 is a bad thing to do necessarily, especially the part about having secure user management system that you can rely on. But like, I don't see how it achieves the goal is what I'm saying.
Yeah.
This particular goal.
What's
Okay,
the-
so we don't find out the answers until after, and we're either gonna pass fail on this thing. Okay, so the next one: which of the following statements is true? For transient network errors, applications should implement retry logic with exponential backoff and fail gracefully if the errors persist.
Failing gracefully sounds like a good thing to do.
Honestly, like that one sounds great to me. I feel like as a test taker, I need to read the other
Yeah, I
options.
just move on.
You just move on. You're so confident.
No. We should probably read the rest.
Okay, so it's better to re-architect legacy applications in one big release so that engineering teams can focus on new applications. Now that I don't feel good about. I like these like lots of small releases with little incremental changes very quickly, not big monolithic releases. So that's why I would rule that out. When rolling out builds to the production environment, consider performing canary testing to perform integration testing before deploying it to production. So I don't even know if that's a proper sentence.
Before going to production, go to production.
I feel like it's like, okay, that doesn't read or parse to me, so I'm going to skip that one. You can review data compliance and sovereignty requirements after you see the source of user traffic. Okay, so that just seems silly. So
Figure out what laws you broke after you broke them.
Yeah, and then just like clean it up later, fix the code. Okay, so we're pretty good. We're 2/3 of the way here. So you have a mission critical application that is accessed globally. You must make sure that your application is able to serve traffic reliably. What is the best way to check if your application is ready to serve traffic? Okay, implement a health check endpoint for each service.
That's sensible.
This is another one of those things where I'm like, yeah, why wouldn't you do that? Okay, number 2, write a cron job to ping your application's homepage every minute. Now, this, I think, as the question you showed earlier, this is one of those things that's like, okay, if I were on an island and nothing else, like no other technology existed, and that's the only thing I had, then I would definitely do that. It's better than not having any monitoring at all. But you have to assume there's some better way to do this in the cloud. Set up monitoring dashboards that your global support team can look at 24/7. Now, the thing I don't like about this is now you have a bunch of humans that are just staring at these monitors, and that's how we know the system is up.
What if they fall asleep?
Yeah, or like, what if they have to go to the restroom or something? So that doesn't seem great. And then ask your testing team to run the tests every day. And it's like, if you have computers, why are you making people do this?
What about Sunday?
Yeah, exactly. So this is, does everyone feel good about these answers here? And I'm going to submit this and we'll see how it goes.
Let's see what we got.
Okay,
Whoa.
we're good. So that's great. So should we do the next quiz? Is that
Yeah.
okay? Great. I hope people are finding the quizzes valuable here. So let's see what we have. Okay, which of the following is considered a best practice when developing cloud native applications? First option, store external dependencies such as jar files or external packages in your code repository to avoid confusion. Okay. If you watch the video, they literally tell you not to do this. So, and that's what I'm talking about in the videos. Like the videos have great suggestions, especially for people who are new to this stuff. Like, here's why you don't want to put your individual config settings in your repo. Here's why you don't want your secrets in the repo. Here's why you don't want these big artifacts in the repo. tomorrow, and here's how you do want to do them. And so it's great stuff to think about. Okay, using the worker pattern, which I'll put in quotes because that's obviously a thing they're talking about, like a specific thing. Develop workers that share state to reduce data storage costs. So does anyone want to talk about this one? Any thoughts on the worker pattern?
What is it?
What does it mean to share state
Huh.
between workers?
Good question.
So worker pattern actually sounds kind of good to me because like if I don't really know that term before, but what it makes me think of is that you have all these jobs and then you have all these like independent workers and they can take jobs. That sounds pretty cool. But then the shared state thing, that also is literally something they call out in the videos. Like you do not want shared states if you're trying to scale something, because if you have like some file or some database or some little server in the middle and all the other things that you're doing have to talk to that to get stuff done, then that becomes a hotspot. And that's your big problem. How do you scale that thing? And so if you can design it in a way where there isn't a hotspot like that, that's better. So shared state here.
And it ties in what we talked about earlier about decoupling. If
Decoupling.
all your workers now are stuck together, they can't.
Yeah, they all
do work
rely on the
independently.
same single thing, then they're all dead at the same time. So I think the key call out here for someone who's trying to pass this test is shared state is not good. That's why you want to rule this one out. Implement API gateways to make backend functionality available to consumer applications. So when I first read this one, I was like, I don't know, is that really related? But then when you think about it, like what would be the alternative? This is when people are just like poking holes through the firewall or just like making random backdoors to get into functionality. And so using like a legit API gateway in the cloud where it's a managed service and it has all these like logging and SSL on it, that sounds like a pretty good thing. The last one is store and manage log files alongside your application for quick troubleshooting in case of errors. So anyone have any thoughts on this last one? Any of our people online as well?
Thoughts?
I think this may like tie into like the coupling, because now you're kind of like coupling your log with your like application.
Yeah, another thing about this is like in the cloud, when you have these, not just Google Cloud, but you have what is it, Datadog and all these different things. It dedicated service where you send all your logs to and they aggregate together, and then when you're trying to search for something and look up an issue, you have all the logs like together, and they're not with the app, because if like the app is down and you can't even get into the app,
You have to
then
log the server.
yeah, like what, how do you do it? So like an external service that's separate from the application is a good pattern. So we're gonna go with API gateway. We have some agreement from the
Peter
folks.
saying 3.
Okay, so far everyone's in agreement on this one. Okay, identify 2 key aspects of this application's architecture. Let's see if we can actually make the
Yeah,
architecture
I found this
visible.
diagram so hard to read when I was.
Yes, I have a lot of feedback about this particular course. So what we have here is a top thing called the app, and it has a box called the UI layer with an arrow pointing to the right, to a separate box called the business logic layer with another arrow pointing to the right, with a third box called the data access layer. And that whole app, as a sort of grouping of things, is all like related and tied to this database backend.
I got this one wrong, so but I'm with you. I got feedback.
Yeah, okay. So, and I'm sorry I can't necessarily keep the picture here with all the, well, maybe I can. So the application is monolithic.
So what's the prompt? We are trying to find the right.
Oh, so we're trying to just identify 2 aspects of this architecture, 2 things that are true that describe this architecture.
2 true statements.
2 true statements about this picture here. So the application is monolithic because all layers need to be deployed as a single unit. And I'll echo that I also didn't get this question right the first time.
I think it's true, no? Because all layers are communicated in one app.
So from this diagram, you could say that maybe that blue box means that's everything.
Yeah, you could say that, right?
Yeah.
But then in reality, this is a whole picture, and there's at least 2 separate distinct items, and maybe there's 4 or 5 distinct items in here. Okay, so the layers of this application can be scaled independently. Well, that's what you were just referring to earlier, right? That doesn't.
Well, it looks like the business logic and the UI, the data layer access are together. Now, I don't know if the database could be moved independently, but at least the
Yeah,
actual database.
I really don't. I think this is a difficult question that if you are faced with this one in the exam, maybe don't stress too much about it and just like let it be one of your wrong answers, because I think there's a lot of ways this diagram could be perceived. And I don't think it necessarily is as clear as it could be. So let's just finish the choices. The application has microservices-based architecture because the code is divided into UI layer, business logic layer, and data access layer. Again, I think that's kind of unclear. We didn't, even in the videos, there wasn't like a clear thing that was like, this is what microservices are, and this is not microservices. And so,
But I think in general, when you say the microservices, can it be deployed as multiple things that talk to each other?
right.
Right, and it looks like there's just one thing.
It does look like one thing. The application will require longer development and QA cycles as the system grows in features and complexity. So again, I think that's true.
What you can get from
Yes, I'm with sounded.
Did we have so we have one as do we have 1 and 4 is what most people are saying on this one? Okay, we're saying it's monolithic and it'll just be hard to build on because all the pieces rely on each other and so forth. Okay, so we will find out in a moment. Let's first do the last question. I think that's the last question.
I think there's 3. That was 2, and then there's 3.
This one requires 3.
Yeah.
Identify 3 aspects of a sound architecture for continuous integration and delivery, which is a CI/CD system. Select all 3 correct answers. Okay, so Docker container images are stored in cloud storage for easy versioning and retrieval. How do people feel about that? This one is one of those ones where I'm like, are they trying to trick me into being like, no, dude, you're not supposed to use cloud storage. You're supposed to use artifact registry. But then I would argue with that person because I'd be like, well, where does artifact registry store those images at, yo? And they'd be like in cloud storage. And I'd be like, so that I think that's genuinely confusing.
I think 1 is wrong, but if you know too much, like Lucas, it's confusing. If you didn't know too much,
yeah,
artifact registry.
Yeah, you should use artifact registry as a sound design rather than using cloud
Computer has a
storage.
good point. They could be stored, but they are not. I think we're taking the LSAT here. All right.
Okay, great. Developers can also build container images on their laptops and deploy to the development environment.
Should you deploy the product on your laptop? Anybody?
I think one of the things this is touching on, and this is a very timely topic because I think this is about to be a lot more talked about in the industry, but it's this whole like software supply chain security thing that we've sort of been ignoring industry wide for a while, and now everyone's trying to figure out, well, what do we do now when we're all dependent on all this ridiculous software. I don't know if you have that image from XKCD of like the dependency tree. We could throw that up at some point, but this is like you want to have a secure place where the images are being built that is a known quantity, that is repeatable and documented, so that when those images eventually make it into production, you can say like what it was that was built and how it was built. And having each developer doing this on their personal laptop is not a good way to make it reproducible. This is also, I think, sort of a call out. Like Google has a new product that just got announced a couple of weeks ago called Cloud Workstations, where you can create these very controlled development environments. And maybe in the model of Cloud Workstations, the answer wouldn't be the laptops, but you would say, yeah, they could totally build it on their Cloud Workstation and deploy it because like we know everything about how that is put together. Okay, so when a developer commits code into the code repository, a continuous integration tool such as Jenkins builds a container image for the application. Anyone?
So you commit changes and it's continuously built.
Yeah, and you have something like a Jenkins or maybe a Cloud build or whatever, and the image gets built. I feel great about that. That seems good. Canary deployments can help catch unexpected issues before they affect a large number of users in production. What's a canary deployment?
The bird?
Right.
Is that like an A/B test almost?
Yeah, I mean, do you know how canaries are used normally, like in coal mines and stuff?
It doesn't work out well for the canary.
No, it's not good for the canary. But even if you didn't really know what a canary deployment was, I think this question does a good job of kind of describing it. And also knowing about the coal mine thing helps, and being like, okay, so if I do this canary thing, then I'm going to catch something earlier.
What it is, right, is you deploy a small version of your route, and then you just make sure it starts. Like nothing catches fire, and that something can reach it, right? Just make sure that there's nothing really terribly wrong.
Yeah, you didn't blow the whole thing up.
The canary is still alive.
And it's a quick enough test that it doesn't take like all day to run like your normal integration tests might take. And it's like a good go, no go kind of thing. So let's do that. Builds should be tested in the development environment, and canary deployments should be used before fully deploying the build to the production environment. This is a solid set of things right here.
Production.
No, we're actually testing in dev.
That's good.
Okay, that's good. So
we need 3.
Are people in agreement here? I'm gonna hit submit and we'll see how we do. There's that one question I'm really uncertain on. So okay, well, we did talk through it together, and Joe and I both did this yesterday, so luckily we were able to get through that one. Well, great. Congratulations, everybody. So now the next section is getting started with Google Cloud development. And we have a bunch more videos here, which again continue to be valuable. I don't think any of these videos are like a waste of my. If maybe one of them was like, oh, I already know all the commands for that thing, you know. But most of them were like covering the breadth and the depth in a sufficient way that I was like, yep, just learned another thing, and like, how do I keep learning a new thing here and there? So please find some time.
College, I feel like if I had known all that before I got out of college, I wouldn't have had to make 12 years of mistakes.
Oh yeah, for sure. So we have getting started with cloud development, and then a practice quiz. Is that the first thing right here? If I can get this video to go away. Okay, let's see what we got here. Having a little internet. Oh, passing score on this one is 100. Well, there's only one question. So we'll see if we can figure this one out. Again, these could be quick trick questions. Like in one of the videos, it absolutely says that the Google Cloud SDK includes the G Cloud tool and the client libraries. And so I'm like, well, okay, those are part of the SDK. But is that what they want me to say here?
So what are these things? Should we just tell people? No,
Yeah.
if we don't know what they are?
So the first one is listing 3 CLIs, BQ, GSUtil, and G Cloud. So BQ is the BigQuery CLI, which you can use to like basically, maybe you can make a data set, but you basically run queries with that. So at a command line, you can just do a BigQuery query and get back some JSON or CSV or whatever. That's pretty useful. The GSUtil tool we referenced earlier, that's the command line tool explicitly developed for interacting with cloud storage. That's how you make a bucket, change ACLs on a bucket, things like that. And then the G Cloud tool is like the Swiss Army knife. Like, depending on what your second argument is after G Cloud, you can talk to basically any API that they have, except for like storage and BigQuery, which are like weird. So as we referenced earlier, there is an effort to bring the GSUtil functionality into the G Cloud storage command. gRPC, if folks are familiar with like,
Have you heard of this before, gRPC?
Yeah,
Kind of.
yeah.
Vaguely, it's like instead of having to implement a server, or I'm not exactly sure, but basically you can set up like, I asked about it in the Slack one day. I forgot what it meant.
Yeah, so it's understandable. I actually haven't personally like written any gRPC code myself, but I've worked with gRPC functionality. But I think the G might stand for Google.
Yeah.
Google RPC, and so if people are familiar with REST APIs, where you have like typically you're posting some JSON data to a certain URL, gRPC accomplishes that through binary workloads, which are much more efficient. And so Google's libraries, like all the client libraries, if you were to install like the Google Cloud Storage Python client, and then you write a little Python code using the magical Pythonic library from Google, that's using gRPC when it talks to the APIs. But then usually when I'm talking to the API, I'm usually using the REST endpoints myself.
Essentially, the core value of it is you can define, like, here's my API looks like. You know, I take a widget and I'm going to have a method called getWidget, right? Normally, you have to come up with like your client on both sides to serialize it, to send it over the wire, to deserialize it, turn it back into an object. gRPC does all that for you. You write a little gRPC doc, and you hit a button, and now you have a Go client. Now you have a PHP client. Now you have a JavaScript with a Java client. It just makes everything for you, and it makes it super compact. But I think JSON is more popular.
Yeah, JSON, because as a human, right, like I can actually go in and look at the log and be like, oh, JSON, I can read that. I know exactly what it is. And gRPC, in order to be so efficient, it abstracts out a lot of the stuff to the point where you can't see it as easily. So let's try this. Oh, the client libraries, I'll just say, are on a number of very popular languages. And I say it that way because I think one of the questions asks you if the libraries are available on every language. And that answer turns out to be wrong because it's not available on every language, but just the ones that you actually care about, it is available on. And so Google has designed like a sort of native experience for interacting with these APIs for each programming language. So I write Python. If you write Python, and you have Python has certain ways that you deal with objects and classes and the way it's structured and the way people typically interact with things. And so when you work with the Google Python client for storage, like it just works the way a Python person would kind of expect it to work. And then when you're a Java developer and you're using the storage client for Java, it's very familiar to a Java person. So it's not like Google did this thing where they're like, oh, we just decided how the clients work and all the clients work that way. And no matter which, platform you're working with or which language you're working with, you have to adjust to the thing we decided. They have come and met the developers where they are and been like, oh, that's how Python coders work. Well, let's make a client that works the way they want. And then they did the same thing with Node and with Go and so forth. So the client libraries encompass all those individual specific library specific clients that were developed for all the many APIs.
And can you just grab this link I just put in there? So we got
Of course.
I just wanted to show people how pervasive these clients are. Like, you shouldn't have to go and start writing gRPC or REST code yourself. Like, this is an example of the Node reference, and you'll see there are like a bazillion libraries Google made. Like, every single thing you can do in the cloud, there's a library for it. And if you drill into any of those libraries, there's going to be like 100 examples, like all the code you need. So when I'm trying to do something like I need to make that lifecycle policy in a bucket from Node.js, I just go to the storage link here. I scroll down to like 100 examples to exactly what I want. I copy and paste that code, and I ship it. And I pretend that I'm a professional. But they've really covered so much in all these clients that everything you could really need to do is already documented in their example.
Yeah, it's really quite good. And as someone who was writing against all these APIs before there were clients, before they had made.
I just want to show those examples.
Yeah, of course.
A bazillion examples. Yeah. So we're gonna say.
Oh, so if I click on this, it's just going to open in Cloud Shell and show me exactly how to add that. Yeah, that's amazing.
Straight into Cloud Shell, into Google Cloud, and run the example.
That's so useful. Yeah, so I was using the REST APIs directly, and so I'd be looking at the doc and being like, oh, you go to this URL and you post this format of data. But then, then there's a Google, like a REST client that just works generally, an auto discovery client. It hits the auto discovery endpoint to see what APIs exist, and then it builds a client on the fly based on that. And that is more like I was describing earlier. It works. You interact with that API, regardless of what language you're using or which API you're talking to, it has the same sort of interface. Whereas when you use the Python client, it's just super like magic and Pythonic, and things that take 10 lines of code with the normal API are just like 2 or 3 lines of code with the client. So highly recommend it.
They try to make it idiomatic, so the Python thing works like Python code.
Exactly, that's my favorite part about it.
If you do it in Java, you get to write 300 lines of code because that's what Java engineers.
People like doing that, you got to give them what they like to do.
Do you think there's like one of these labs you could let folks run through with us?
Yeah, absolutely. Do we want to take a quick vote? So for each of these labs, we can do a Node version, a Java version, or a Python version. Does anyone have a preference? Because I can pick any of them.
On the remote side?
Yeah, I'm looking in the chat here. Any Go? We don't have Go, unfortunately, Peter. Hopefully the next year we will.
What are you guys using in school right now?
C.
Okay.
Oh, bummer. Well, we don't have any help for you.
Okay.
Well, so I'm a Python person, so I'm just going to pick on the Python one.
Okay, Python.
Okay, Python is what we're doing. Retake unallowed.
Cool. Well, then here, I'll take it.
Let's see if that's true or
You
if
wanna throw
that's
the
just
link?
a bogus.
You wanna throw
That
the
might
link
just
in
be a bogus
for
thing.
folks?
Yeah.
So for anybody that joined today, we'd just like to make sure you can actually try to jump in and take a quick lab, just to make sure that, you know, all your stuff's set up right.
It's bogus. I was able to get in. It started the lab.
Cool.
So whatever that error
what do
was.
you guys do? I
was
just want to make sure you have the credits. And you can
Yeah,
put in.
we're not. I don't think we're set up in the Google Cloud thing, but
Sure. So if you just go to Cloud Skills Boost, Google, it's in the URL up there.
I already started this lab.
Which do we sign in with our like personal Google account?
You should sign on, yeah, but it should be ideally the same one that you used to sign up for this event.
When I click on the link, I get access denied.
You get access
Now
denied.
you're in a session. Here, 1 second. I'll get a better link.
Oh, did I send the link of my actual session instead of the
Yeah,
top
yeah.
level thing? My bad.
Oh, baby.
Thank you, Joe. Let me just delete that link then, so it's not confusing. Okay, getting started with application development.
There we go. Here is the level we're working on here.
Okay.
And do note, this says it'll take you 2 hours. 1 second. Did I send them the right one? Setting up.
I'm gonna do a thing where I'm gonna reshare my screen here as the whole screen instead of just one window. Okay. So we good? Great. So I'm gonna just quickly get started by logging in here, which is you have to do, and it becomes a little repetitive. You copy the username, you copy the password, as Joe showed us last time. Oh, they didn't make me accept anything. That's interesting. And then I'm gonna make sure I select this project. Great. Copy that. So now let's go through what they want us to do here. In this lab, you set up a Python development environment on the Google Cloud. You then use Compute Engine to create a virtual machine and install software libraries for software development. You perform the following tasks: provision a Compute Engine instance, SSH to the instance using, or connect to the instance using SSH, install a Python library on the instance, and verify that the library was installed. Overview. Compute Engine is just one resource provided on Google Cloud. Google Cloud consists of a set of physical assets, such as computers and hard disk drives, and virtual resources, such as virtual machines, that are contained in Google's data centers around the globe. Each data center is in a global region. Regions include Central US, Western Europe, and East Asia. Each region is a collection of zones, which are isolated from each other within the region. Each zone is identified by a name that combines a letter identified with the name of the region. For example, Zone A in the East Asia region is named Asia East 1A. Should I read through all this? I'm trying to decide if that's a good way to do this. Yeah, let's just keep doing that. The distribution of resources provides, what's happening? Credits? Oh, okay.
This is a page you want to open.
Yeah, it's good to always open in the incognito window. Sorry, folks, we're just figuring out some technical issues in the room.
Before you click start lab or after?
You click start lab in your normal session, and then when they're like, you need to open a window and log in, that should be in an incognito window. So when you go to Cloud Console, you're going in an incognito window. Which is what I'm actually doing here. This black window on the right is my incognito window, and the one on the left, I'm logged in with my normal Google account. Okay, the distribution of resources provides several benefits, including redundancy in case of failure and reduced latency by locating resources closer to clients. This distribution also introduces some rules about how resources can be used together. Oh, so one thing you can do actually when you're doing this, if you're doing it on your own time, you can like read all the stuff, the whole thing before you click start, and then you're not losing any time. But I will tell you, I'm not concerned because this session, which gives you 2 hours, I did it in like 5 minutes when I did it by myself. So hopefully even I can't talk so much that I will use up all 2 hours, but we'll see. Good challenge accepted, Joe. Thank you. Any cloud resources that you allocate and use must belong to a project. You can think of a project as the organizing entity for what you're building. A project is made up of settings, permissions, and other metadata that describes your applications. I think most of you have probably have you guys like made Google projects before and spun up anything previously? Yeah. Okay. I think a lot of folks have done this before, so that's good. Resources within a single project can work together easily, for example, by communicating through an internal network, subject to the regions and zones rules. The resources that each project contains remain separate across project boundaries. You can only interconnect them through an external network connection. Each project has a project name, which you provide. In this lab, the project name is the same as the project ID. The project name is just like the pretty like capitalized with spaces in it name, and the project ID is the lowercase name with hyphens. And then they also have a project number. As you work with Google Cloud, you'll use these identifiers in certain command lines and API calls. When you open and log into the Cloud Console, the dashboard provides the project info. Okay, so we can see there's some project info, project ID, project name, project number. Each project ID is unique across Google Cloud. Once you have created a project, you can delete the project, but its project ID can never be used again. Is that true? I didn't know that. I don't think that's true.
Yeah, I mean, yes, it's true, but if we get to the nitty gritty, projects have a number, they
Right,
have a name, and they have an ID.
right.
The name can be reused. The ID, if you ever make a project called like Hello World, the ID is actually gonna be like Hello World 2565B because it has to have an ID that's unique, but the name can be non-unique. Anyway, that's going deep into the whole.
I just don't totally agree with this because I think you can delete a project and wait like 90 days and then it becomes available and then you can create it again. But whatever, we won't get sidetracked.
The name does.
Okay.
Those piece of lies.
When billing is enabled, each project is associated with one billing account. Multiple projects can have their resource usage billed to the same account. So that's a key thing as far as understanding the structure of Google Cloud. A project can have a billing account linked to it. If it does not, it can't do anything that requires spending money. It can only do free things. If it has a billing account linked to it, it only has one billing account linked to it and no more. And that billing account can have many, many, many projects associated with it. In fact, you can exceed whatever Google's theoretical limit is, and then you can't use your billing account anymore, which I can talk about another time. A project serves as a namespace. This means every resource within each project must have a unique name, but you can usually reuse resource names if they are in separate projects. So like you could create a VM in one project that has a certain name, and you could create the VM with the same name in the other project because they're not in the same project.
But I guess we're on that subject. A few things can't have to be unique globally. Project IDs have to be unique globally. Buckets have to be unique globally.
Yep.
So sometimes if you just started a new company with a really unique name, go get your bucket. And that means that no one can ever have that bucket. You know?
Yep. That's true.
It's the same in Amazon. There's a few things that are globally.
And that's just like a feature as well. The idea that when you are trying to access data in your bucket, you don't have to choose which region and which zone and all of that. And when you tell a user to go download it, you don't have to tell them all those things. So that's a win, but it also means that you're playing in a single global namespace. So obviously, like when I went in to create the bucket called Broad, it was like, I guess that one's taken. Someone might have already made that bucket. Hopefully I haven't used up my 2 hours yet. Good deal. Where did we leave off? Okay. Ways to interact with services. Google provides 3 ways to interact with the services and resources. The Google Cloud Console, which is what I have on the screen to the right here, and what we're going to be doing all this work in. The command line interface, that's again the various CLIs and stuff that we were just talking about. And the client libraries, that's when you're going to write some code and you import Google's library for cloud storage, as Joe mentioned, and then you write some code against it. So setup and requirements. So this is where we have to get started and where we're supposed to click start lab. So you wouldn't have already spent 12 minutes at this point. And then what I did, obviously, just to reiterate, is I created an incognito window over here because I don't want to add like 200 random temporary accounts to my Google browser. And I went to console.cloud.google.com and I just logged in with the username and password that is provided here in the Click Labs window. So we're all set with that. We have the Cloud Console opened. We already did the credentials. Now it's time to create a compute engine instance. So now we're going to do some stuff here. So let's figure this out. I'm just going to scroll this over a little bit here.
Well, can you show them how to get to the cloud shell? Because I think this is the coolest thing about the cloud.
Oh, okay. Well, you know, I haven't been asked by the
sorry.
session yet,
Sorry,
but
sorry.
I'll just jump ahead to that, Joe. So right up here, if you can see, which I think you can, my mouse, you can click on Activate Cloud Shell, and it'll, in the bottom portion of the screen, it'll open a terminal window that's built into your browser, which is in Google Cloud, and which is running in the given project, and so you can start doing things.
But all those tools we talked about are pre-installed, pre-configured.
Oh, that's the best. Like if I'm working with someone on like a problem, we just need to run this gsutil command, and then they're like, "What's gsutil? I don't have that on my computer." And I'm like, "Oh no, are we going to spend the next 20 minutes figuring out how to install gsutil on your computer?" No, we're going to open a Cloud Shell, and it's just going to be there automatically. So you just like gsutil, boom, and then I can start doing whatever I need to do. So that's good. So let's start with the task at hand and see if we can do that without getting sidetracked here. So the first thing we need to do is go to the compute engine section of the navigation, and automatically it takes you to VM instances. So we're in good shape there. And they want us to create an instance. So I'm going to click create instance. And folks, feel free to follow along. I don't know why that was so many F's in a row.
Follow along or speed ahead.
Feel free to follow along on your own, or you can do this separately at home when you want. Yeah.
So is that terminal only available on Google Chrome?
No, that terminal, does it only work in Chrome? I feel silly, but I can't answer that because I only use Chrome, so I don't actually know. But I don't know. Maybe someone can test it and tell me if I think it would work in Safari or other browsers as well. But I actually don't know off the top of my head. So thank you for asking that. We will figure that out and get back to you. So I will say that when you're doing these, if your goal is to like not just learn the stuff, which is awesome, which is the primary reason you're here, but if you want to like complete the thing and like earn the badge, then you have to follow the directions. So if you just like leave it as instance 1 and then create it, when you go to check if you finish the lab, it's like, no, you didn't finish lab because they were telling you right here to call it dev instance. And Joe and I were chatting yesterday as I was going through one of the labs, and I got distracted and I did the whole lab, but I picked the wrong zone. And I got to the end, I was like, am I good? And it's like, no, you're not good. And I'm like, why not? Again in the correct zone. So be careful about that. So I'm they want the region to be Central 1 and the zone Central 1A. So luckily, that's the default. But guess what? I went through 3 of these in a row. The first one was Central 1A. I was like, sweet. The second one was F, and that's where I missed that they changed it. And then the third one, I like mistakenly did F again, even though it was A again. So just try to, this is not supposed to be a test of your reading comprehension, but it turns out it can be at times. So then they want us to scroll down to, and you'll find this in many of the labs, because the point of this lab is to like install some little piece of software that's going to call a Google API or some such thing. And so you need to set your VM, which by default only has access to do like logging and monitoring and a few basic things. They go the easy route and just like give it all the things. If you were doing this in the production, you would figure out, what does this application need to do and which scopes should I give this VM so it can do just that. But because we're just trying to get through this learning process, we're going to enable all access like they told us. And they also mentioned that we should allow HTTP traffic. You saw Joe do this last week. This is just a sweet thing because you could just check this box and allow it, or you could go like make your own firewall rule and all that kind of stuff. And who needs to do that when it's magic?
But do distinguish the difference between HTTP and HTTPS.
Oh yes, that is an important thing. All the traffic these days wants to be HTTPS. So like if you were doing this at work in production, I'd be like, why are you even enabling HTTP? But again, for these simple examples, they don't want to have the whole step where you have to like go register a certificate and figure out how to install it and create a signing request and all that. So it's pretty straightforward here. We're just going to allow HTTP and see if we can get a computer on the internet to run some kind of web server, and then if we can hit it from a remote place. So it is creating. So if I jump ahead and hit like check progress, it actually can see. I think this Quick Lab might actually be checking the audit logs to see if there's an audit log entry that says the user created a VM in that region. And even though the VM has not completed being created yet, I got a green check mark because they did see in the logs that there was like, oh, user created a VM in that region, and they're like, good to go. So we have green, and over here we have green as well, so we can see the instance was successful. So now they're telling us on the VM instances dialog in the dev instance, click on SSH. So right here, we have the link to click on SSH, and it's going to bring up another window with an SSH connection to the server. That worked. I'm pretty psyched about that. So not only do we have this computer up and running, but we were able to log into within a browser, which is just kind of cool, actually. I still think it's cool that I can do these things in a browser that used to be just like I needed this whole special thing.
Even a year or two ago, if you were on Amazon, you're trying to make your keys, save your keys, install your key.
My gosh, the keys.
Install PuTTY, try to connect to the
All the
server.
keys, man. Jeez.
Here it's just one click.
So now we're going to get to some copy pasta, which is a lot of what this lab is. So, and this is a pretty repetitive set of things. Like I mentioned, there's 3 labs in a row that are like, set up your dev environment. And the first one is Java, or the first one's Node, the second one's Java, and the last one's Python. And you have to log in to a computer and you have to update the application packages. So that's the same for all of them. And also this thing where you have to install Git, that's the same too, because this instance image doesn't have Git on it by default.
Cloud Shell does.
Cloud Shell is superior in many ways, but actually, I really am a big fan of Cloud Workstation, so we'll talk about that more at a future event. Okay, so we have Git installed. The reason they wanted us to install Git is because we're gonna in this one we don't even pull anything down with Git in this particular one. Okay, here we're installing the Python 3 setup tools, the dev environment, and the build essentials, which are just, if you're a Python developer, these are the things you need to be on your machine to be building stuff. And that takes a moment. It takes a few moments, actually. A couple
You
moments.
guys see why serverless is awesome? This is what happens when you use a server.
Mm-hmm.
I have a question.
Sure.
It somehow is able to check your progress with this. How does it know what you installed?
So, checking your progress of whether you installed the package.
Yeah.
Yeah, like if you're logging in like SSH and checking.
Yeah, I mean, because they created this project for you in their org, so they have service accounts. They're logging in and checking.
I bet if you went to the user log.
Yeah, you probably can look in cloud logging and see that there was some kind of SSH connection where it ran a command and it returned like that was the whole point of this, was like, how do you make it so that you can create like a a cloistered environment that the user can use to not hurt anything, but then you also can look at it and can ping it and can control it. So it's pretty clever. Okay, so we finished installing that stuff. Now they want us to install pip. And again, I'm like, what are these computers that you build that don't even have pip on them? Like, come on now, people. And then finally, now we're going to actually install pip, not just get the okay, so there we go. We have pip. So now we're just like a full-on cloud Python developer here. We can just build stuff to our heart's content, and that's amazing. Okay, so there is more to this, and I think we will have to actually get something in a moment. So let's see what's happening here. So here we're going to verify the software installation and run some sample code. Cool. So they want us to just double check that we have the correct version that we expected of Python.
Can you blow up the size of your?
Yes, I can. Thank you. Thank you. Let me fix this. Oh, can I? Yes, I can. Boom. Maybe that was too big, but we'll see. So we'll check the pip version as well. Great. We have pip 22 thing. Now we have a repository. And I will admit, this repository that I'm cloning is cloned in every one of those videos where they're showing you like, oh, we're going to do a thing. Let's clone this repository. And videos, this clone takes less than 1 second. And I'm like, what? And I think maybe there's like a video editing in and making this look like it takes 1 second when it really takes like a minute.
This thing's running at 250 megabits.
I know, come on. It's not like I'm on some weird like 10 connection here or whatever. But either the Googler who's running this is on like has the GitHub repository local somehow or whatever. But it's just instant when they do this, and I'm like, where are you doing this that it's instant? And that's why I had to just talk through all that to try and make it seem not so long. Okay. So, and again, all of these, what they're doing is they're pulling down a repo that has a whole bunch of code repositories in it. And because the thing we're working on is like this Python, whatever thing, there's some path in that directory that has that Python environment. And you just make a little soft link to your home directory with that path in it. So you're not copying anything in, you're just accessing it in the repo, but there's just a little link there. Then we're going to change directory to that new place that we just set up. So here we have whatever this thing is they want us to do. And okay, there's some server.py in here. So as any good secure software person, I'm just going to randomly pull this down and run it as root on my computer, right? That's what you do. Okay, so it's doing something. That's very exciting. Control C to stop. That's a little anticlimactic, but whatever. So now they want us to return to the console, look up the compute engine instance, find its IP address, and then see if we can go to that. So here's the instance and the console. Here's the internal IP. That's not what we want. We want the external IP, and there's this like handy little whatever arrow thing that I can click on. Hello, GCP dev. So there's totally a web server running on there with Python. And in fact, like if we look at the thing, we can see like right here, there was some hit, to this page. And that was me going to the page just now. Actually, this one is me going to the page, these 2 lines here. This other one might have been the machine itself.
The quick lab, it's checking.
The quick lab. Right? Yeah, exactly. That was, but I just a second ago. So did the quick lab, was it polling?
Yeah, it has completed, score is 50. So I think it ran the test.
No, I haven't.
Let's try pushing the button and see if it calls.
Yeah, let's look at what happens here.
Score says 15.
Boom.
Okay.
It did it.
Where's it coming from?
It's coming from the host itself. So like that is the IP address of the machine. And on the machine, it just like checked itself.
So like they staged in and then we'll
yeah, they just check yourself before you wreck yourself here. Okay, so now they're saying I can Control C out of this web server and kill it, and we'll do something else we need to do here. So now we want to install, like we had just a very simple web server that just printed out a string of text. So now we want to install this, whatever this app is. So it has a bunch of Python requirements. It's pulling down, and now it has built and installed that. That's exciting. Then we're doing a thing here that doesn't look like it's good to copy paste. Thanks, Google. Some of them are a little bit better, actually. And there is a thing. What is it?
Print, there we go. Environment dump.
Yeah, but I thought that there was, what's the variable called? Is it like dev shell? Oh, I'm not on the Cloud Shell. I'm in SSH into the VM. Right, so it's not. So I need the,
They're on the sidebar, I think.
yeah, exactly. So I need the project ID from here. So I'm gonna fix this. Oh, I didn't copy that very well, did I?
Where's it come from?
Oh, on the other side there is. Yeah. Okay, we have that. And then we also have the Quick Labs project ID and then zone. And we did it in US Central 1A. So this is going to list all the GCE instances in this project. That's why we had to enable those APIs earlier, because we were going to use this compute engine API. And it says, okay, here's all the instances in your project. There's one called dev instance. Amazing.
Wow.
So we were able to get through that. We got the output. Let's test our understanding here. Here's a little quiz, everyone. Okay, so pip is a package management system used to install and manage software packages written in Python.
I don't know.
Okay, I'm going to go with true on that. It's really hard to argue with that one.
Peter got it.
Excellent participation from the online crew. And there we do. We just finished a 2-hour lab in spite of the fact that I've just been talking like crazy in less than 30 minutes. So hope everyone learned something there. I'm going to end this lab.
So if you had maybe an hour and a half a week to put into this, you could probably get through all of these.
I would say if you're not like ADD like me and you can just sit down and start something and finish it, it probably won't take very long at all. If you get distracted like 200 times in the middle and then you're like, oh, I watched the first minute of that video, but then I missed the rest and I have to watch it again, it could take a while. But it's each person has their own style, I guess. So what I'm not going to do together with us all here, all in the room, is do that exact same lab 2 more times. But if you want to get the badge, you do need to do that. I will say. Let's go directly to the quiz, since that's been kind of fun. Okay, I'll even make it a little bigger here. Which of the following statements about Google Cloud Client Libraries are accurate? Cloud client libraries handle low-level communication, retry logic, and authentication.
I like that.
That sounds plausible.
Yeah.
We're looking for one wrong answer.
Only one wrong answer. That's a good call. So odds are, and all of these are right, is the odds. Oh, my project is deleted, so I've been logged out. Good to know. Because when you stop the lab, it then just deletes all the stuff that it created for you. Cloud client libraries are helpful because they support a language's natural conventions and styles. We actually talked about that specifically, so that sounds good. Idiomatic is the word for that. Cloud client libraries are the latest and recommended approach to making requests to the server. Well, that seems viable. And then I gave this away earlier tonight, but cloud client libraries are available in all programming languages. Now that word all does a lot of work in the sentence. And I'm sure that if we put our heads together in this room for the next 2 hours, there's no way we can name all programming languages. And so if somebody was able to make client libraries for all of them, that would be amazing. So we're just going to skip that one. But there is like the ones we care about, the ones we talked about, Python, Node, Java, Go is what I think in the future, hopefully all our stuff will be talking about Go. You have a question?
Yeah, I'm curious though. Like, it says here, cloud client libraries have the low-level communication, retry logic, and authentication. Do they really handle retry
In fact, they absolutely do. That's the amazing thing. So one of the things you will pick up from the session is that if you were writing your own connection to the API and you're just looking at the REST API and writing your own client, then what you would do is you would call the API. If you got an error, you would handle the error. If you got a lot of errors, you would use some exponential backoff, and you would write that into your code. When you're using the client library, you don't write that into your code. You should not write that into your code because Google is already doing that. So like in your code, at the best case, if you use the client library to do something and like it comes back with like, oh, that failed, at the best case, you try it once because Google already did the exponential backoff and everything on your behalf magically as part of the client. So, and the low level thing, I think that's referring to, let me scroll back. That's referring to like what we're talking about with gRPC and stuff. It's not just sending like these JSON dumps. It's having like some real intimate interactions with the other side.
Serializing things, it's compressing and decompressing things. And as Lucas said, like when we run something Maple's Cloud on GCP, when you make a billion API requests, you just start discovering all sorts of weird things you never knew could happen, like socket timeouts, socket hangouts,
Oh, yeah.
DNS resolution failures. And they just handle all that for you. You don't have to know these things exist. They will try and automatically.
I mean, as an example, with the normal Google REST API, even the REST client, the one that's called like the Google API Python client, which is just like an auto discovery client. If I want to get all the users from our G Suite domain, like I get the first page of users, I retrieve the page token, the next page token from that response, and then I get the second page of users. Like my code is doing that. If you have the Python client that is Pythonic and idiomatic, then like it just does that. You don't ever write that looping thing because that's just when you say get all, it gets the first page and it gets all the pages, and then it just gives you the response. So yeah, there's a lot of magic happening. Like for example, like the Google Cloud storage client. You know, when you use that instead of using the REST API, it's doing all the stuff that you're just telling it like, here's the bucket, here's the file, and the rest is kind of magic.
Take the file, cut it into 20 pieces, start loading them all.
Yeah, it's
lots of magic.
Yeah, it's
So if I really get like a 500 level error, that means that they already tried.
correct.
Yeah, usually you'll see stuff in the trace about like retry, fail out, and time, or they gave up, they tried too many times.
I see. So you
Yep.
shouldn't even bother.
Yeah, like not every single API that Google offers has like a Pythonic built-in client for it. In some cases, you want to talk to that API and there isn't like a Google Cloud whatever. There's just like the REST API. And so now you're just talking to the endpoints and you are having to deal with exponential backoff yourself. And but yeah, if there is a Python client, then it is already taking care of that for you.
But most people shouldn't have to do that.
Yeah, not recommended. Okay, your code throws errors because the actual response from a Google Cloud API is not what you expect. You want to quickly find the response values for a set of test parameter values. How can you execute the API with minimal effort to determine the response data? Does anyone know the answer to this without even reading the questions? Like, do you know what you would do if you're like, how do I try out that API to like see what it would do? Anyone online? No, okay. Let's read through the suggestions. Invoke the unit test for your code with test parameters. Okay, I can see why someone would say that. Use the API Explorer to execute a snippet of your code with test parameters. I think that's what they're trying to get us to do. Use the API code to invoke the API. Oh, that sounds better. You actually want to invoke the API, not your own code snippet. And then use the API Explorer to run the equivalent gcloud command. So I'm feeling the best about this one. And in fact, why don't we just take a look at this? We've been talking about storage so much, right? Let's look at the storage API. Okay, storage API. Cool. Let's see, where do I get the JSON API? It's over here. Oh, got buckets.
I just threw an example in there of like another place, but yeah.
Oh, Kubernetes engine, totally.
They'll actually give the docs for every single endpoint.
So here's an API for getting buckets, like, and I'm just looking at it and I'm like, okay, there's a red thing. So that's like, I need to put that in. So I have a bucket I made recently. I decided to start working on a project where I'm like analyzing the spelling bee from the New York Times every day. And so I have a cloud function at 3:05 a.m. when the spelling bee goes live at 3 a.m. So at 3:05, my cloud function runs. It downloads the blog post. It parses out the details and it returns it as JSON, puts it in a bucket. So we can get the bucket. I don't know actually if I have permission to get this bucket. So this might give me a permission denied error. Yep, permission denied. Wrong user account for getting that
That's how
bucket.
you do it. If you can just scroll to the bottom, I just want to show one other thing that's cool here. They show you the permissions at the bottom too, right? Don't they show you the IAM permissions? And...
Not on this page. Oh,
Okay. Well,
yeah,
what I
it
was
doesn't
gonna
tell
say
you the
is,
permission on
usually
this
these
page.
docs, they're going to tell you what you put in, what comes out, any extra funny business, what permissions you need, like everything that actually needs to happen to make that API work will be documented.
Let's just try this. I was able to, on the one account that I was using, I was able to copy the URL here, and it actually has like all the parameters that I had just put in. So if you're working with your teammate, you're like, I got a 403 error when I tried it. You can send them the URL from the browser, and they can put it in, and they get the same exact screen with all the fields filled in the same way. So this is a different account, and it's possible I have the wrong bucket name, to be totally honest, but we'll just see what this does. Oh no, this is a fail here. I'm not gonna log in on a live stream. Sorry, y'all.
The only guy put in there actually there has like, you scroll down, they give you examples and even give you examples in like 6 different languages. So I don't know how much money Google has spent on documentation, but it's the best of any cloud that I'm aware of. Like I've read the AWS docs, I've gotten lost in there so many times. They do a great job.
I mean, I will say I agree that these have gotten so much better over the years, and not just the API doc itself, but like when you're reading about how to do this function, and it's like, oh, here's a code snippet, and there's like tabs with every single language that you might want to make that code snippet in.
So here you get the request, the body, the structure. They're giving you telling permissions, the scopes it needs, and then here are ways to pick example code for all 5 different languages.
Yeah, so and this little widget that has the example code here, sometimes it will also have, oh, here's the gcloud command. Here's how you do the same thing in the console. And there's a new thing that's just been coming out recently that I absolutely love, it'll be like, here's the Terraform.
Ooh, nice.
So it'll be like, oh, you want to create a bucket? Here's how you do it with Python, whatever. Here's how you do it with GSUtil MB. And then it's like, oh, here's the Terraform, just copy paste. So that is really great. Those docs are growing excellent. I got logged out of the SSH. Okay, maybe we can get through this last question. Which of the following statements about Cloud Code are true? So Cloud Code we haven't talked about much yet, but it is a feature that you can add into your code editor like VS Code or the JetBrains products that has all kinds of integrations with Google. Let's see what the question asks us about. Cloud Code integrates with Secret Manager to securely store sensitive data. So it does integrate with Secret Manager. I know that. It's one of the cool features. So let's check that one and see if we have any reason to uncheck it. After, Cloud Code works with Cloud Run and Kubernetes. I think that's accurate. And then let's see what else we have. Cloud Code is a new integrated development environment for creating cloud native applications. That I also agree with. Yeah. And I actually don't know which thing I would remove in order to check that one. And the last one, Cloud Code's YAML authoring assistance provides autocomplete and inline documentation for Docker files. Well, the only thing I think wrong is that it probably does that for YAML and it probably does it for Docker files, but those are not the same thing. So that seems like you rule that out. So does anyone have any thoughts about this third one? Is there something we would uncheck in order to select the third one? Are we good here? Ship it? Okay. So we're skipping that it's a new integrated development environment. What's wrong with that? That it's not new? That it's not only for cloud native applications? I don't know.
And we already did this.
We did this question. What tools? It's these 3 tools, even though you'll hear people say that the Cloud SDK also includes the client libraries. It seems like an unclear question, but let's just ship it, as Joe said. Boom. So I guess the problem with that one is that it's not only for creating cloud native applications.
David said that it's not integrated and that it's an extension or a feature in the intelligence.
Okay, that's fair. It is not its own new development environment. It's just like a thing you add into your existing development environment. So that's why that one's wrong. Good call, David. Juan. Thank you for participating.
Cool. I want to drop out and I'll just finish up the last slides here.
Yes.
Awesome. Thank you, Lucas, for a fearless tour. We survived. Everybody made it. So let me just bring this over. And I'll fill it back up. Second, I need to share the screen. This one. All right, so just almost done. A couple minutes left in the week here. Thank you guys for all joining us remotely and in person. We showed you all how to work in the Quick Labs. You did one of the Quick Labs that's for this week. Well, that's for next week, right? The stuff we're trying to get done before we get together again, so we can go over it and make sure we're moving forward here. This document is shared in the Slack channel. I'll put the link to that again in our main Slack channel. That again is Cloud Developer English on the Road to Google Cloud Developers Slack that everybody's in. And if we remember, that one is going to be the series of labs. Let me just open that up. We're getting started with app development here. And as Lucas mentioned, there's some videos, some other stuff, but this is actually like, this stuff is money. Like, I really wish I had known this years ago before I started doing it. It would have saved me so much pain, so much time. So, and ask everybody to start, try to find some time. You'll see hours written on these things. It does not take as long as those things say. You guys will get through this stuff pretty quick. And finally, we also have the serverless Firebase development series. And that's really awesome. The Firebase suite of tools is really made to make application development as easy as it can possibly be. We use a lot of those tools even here at Maple to run things at very large scale. I think you guys will really find that stuff enjoyable. So that's what folks should jump in on in your free time in the next week. Again, I don't think it's going to take you 5 hours. We got some smart cookies here. Don't be scared off by that. Don't forget, as I just mentioned, the Slack. If you guys haven't joined the Slack, go there. We are the developer group. So again, that is cloud-developer-english is the group. And there's a questions channel in there. If anybody has questions, you can just throw it in there. I know I should have. There's a few times I got in snags. Folks around the country and around the world will jump in and help you. For anybody that's new here tonight, you can also, if you go to this link, and it'll be in the recording we'll share tomorrow, you can get your badge to put in your developer profile as well to show that you are participating in the event and the overall program. And as I said, we've got the whole community out there for you guys. We got Slack, and then there's also some other GDG community tools out there that you can get some help from. GDG, again, is the Google Developer Group, put on by Google. That's what sponsors it. That's who gave us this awesome swag, and that's who gave us the Flopple. And you can also reach out to them if you run into any operational challenges. So that's it. That's a full poll. Thank you guys for joining us tonight here and online.